So for bow work, we graphed all of these. I told you we're working with perimeter and area on the coordinate plane, but we're actually going to start on the other side where we look at some of the vocabulary before we get into actually solving stuff. Okay, so we're going to start with classifying a polygon. A polygon is a closed figure with all straight sides. So polygon by definition, closed figure with straight sides. So a circle is not a polygon. Or another non-example would be like if you have two straight sides and then a curved edge, that would not be a polygon. When we name polygons, we name them by their vertices, so each corner, and then you name them in the order it goes around the shape. So this would be polygon A, B, C, D, E. And that's how you name a polygon. Now you don't necessarily have to start with A, you could start with B, but whatever you start with, you have to go in order around that shape. So B, C, D, E, A would be fine. Pretty simple so far? Okay. Another thing that you need to note that actually isn't on these notes, but it was covered in the last textbook and it comes up later on with different questions. A regular polygon versus an irregular polygon. A regular polygon would have all its sides identical. So I'm going to try to draw the most perfect hexagon I can draw because a regular polygon would be perfect. It has all sides the same length. So all sides are equal in length. And then all angles are the same measure. So it's just perfect, perfect, perfect. That is a regular polygon. So how might this come into play? Later on in geometry, they might say, okay, you have a regular hexagon and all the interior angles add up to 720. What is the measure of each individual angle? Well, since they said it was regular, you know that all the angles are the same, and so you just divide it by 6 to get each individual angle. So it's an important word because it makes something that seems complicated very easy. Regular just means that everything's the same. So to find each individual angle, you could just divide by the number of angles. Irregular polygon might look like this. So I'm drawing a hexagon, but in this case, not all the sides are the same length, and the angles aren't the same either. So that's supposed to be a hexagon. Of course, there's some human error in there. Okay, now we're going to look at convex versus concave. So convex versus concave. What's the difference? Convex doesn't cave into itself. Concave, I use this word concave to remember what it is. Concave has a cave. See that? It's a cave. If it has a cave, it's concave. And then we have this chart over here. You will have to classify shapes by the number of sides. There is usually one of these on the quarterly assessment and usually one on FSA or whatever kind of testing they're doing this year. They might be changing it to FAST, but it's going to be the same idea. So you'll have to identify a shape by the number of sides. Super easy if you're familiar with these. 3 sides is a triangle, 4 sides is a quadrilateral, 5 is a pentagon. These should sound really familiar. 6 is hexagon. 7 is one that people forget a lot. It's heptagon. So 7-sided is heptagon. 8, like your stop sign, is octagon. That one's pretty common, and you probably remember that one. 9 is another one. 9 is nonagon. 10 is decagon, and 12 is dodecagon. Those are the ones that people kind of forget. And then if you have more than 12 sides, n-gon means that you would say, like if it had 14 sides, you'd say 14-gon. Or you could say 26-gon or 302-gon, whatever it is. Okay, so based on that information, we're going to practice a few of the starter questions. It says classify each polygon by the number of sides, and then tell whether it's convex or concave. So this first shape, we have 1, 2, 3, 4 sides. So this would be a quadrilateral. And is it convex or concave? Well, it looks like it has a cave right there, so it must be concave. The next one, how many sides? It has 1, 2, 3, 4, 5, 6 sides. So that would make it a hexagon. And then it doesn't cave into itself, so that would be convex. And we're going to practice these 3 down here. This should be pretty easy at this point. Counting the sides. This has 5 sides, so this would be a pentagon. It has that cave there, so we got a concave shape. Number 2, counting the sides. 7 sides, that's one of the ones that I said people forget a lot. It is heptagon. It doesn't cave, so this would be convex. And then the last one, you may be working ahead of me at this point. That's cool. We got 8 sides, that's an octagon. And it's convex. Okay, I was looking for my highlighter. Okay, we're moving on to the next page. There's my highlighter. Okay, next page. Over here. So I told you that we're going to find the perimeter and area on the coordinate plane. In order to do that, we have to remember what perimeter is and what area is. You probably remember this, but some of you may not. Perimeter is the distance around a shape. And then area is the space inside a shape. If you have a highlighter out, you can highlight those. Ooh, it's smearing. And then they gave us this chart here, which just reminds us of the equations. These are the 4 shapes we're going to be working with today. Triangle, square, rectangle, and parallelogram. They give you the equation for both perimeter and area. To be honest, for perimeter, you really don't have to memorize the equations because you know perimeter is the distance around the shape. So for example, a triangle, you just add the sides up. Same with a square. If you're told it's specifically a square, you know all the sides are the same, so even if you're given 1, you would just add that 4 times or multiply it by 4. Rectangle, to find the perimeter, would be length plus width plus length plus width. Parallelogram, again, this plus this plus this plus this. For a parallelogram, because you do have that slanted side, you might have to calculate that length right there. As far as area goes, triangle is 1/2 base times height of a triangle. The base is right here, and then the height is the perpendicular height, which they show right here. So it would be from the bottom to that top point, whatever that length is. And then area of a square, just side times side. And then rectangle, length times width. You're probably pretty familiar with that, yeah? And then parallelogram, I know that comes up in 6th grade. I don't know if it comes up in 7th or 8th grade, but it's base times height, and it's the perpendicular height. You just multiply those two numbers, and you get the area of the parallelogram. Okay, so moving on to the next page, which is where you did your graphing. So flip it, find this page here. We have some more practice on classifying the shapes. Classify it by the number of sides. We have 1, 2, 3, 4 sides, so this would be quadrilateral. And convex or concave, it has a cave, so that would be concave. Number 2 has 3 sides, so we got a triangle on our hands. This would be convex because it doesn't cave. Number 3, we can see it has 5 sides. Something to also note about number 3 is it does look regular. It looks like all the sides are the same measure, and it looks like all the angles are the same measure. So this would be a regular pentagon. And it is convex. Then for number 4, how many sides do we have? 1, 2, 3, 4, 5, 6 sides. This one would be irregular, hexagon, and this one would be concave. I added the regular and irregular in there because some of the homework problems ask about whether it's regular or irregular, so that way you have an example. Okay, now we're getting into finding the perimeter and area of shapes. We already did the graphing. If you were to get problems on homework where it wasn't graphed, you could use the graph paper here to do the graphing. And we'll just start with the first one. The first 4 is looking for perimeter. So as we do these, we're focusing on just perimeter and not both perimeter and area. And perimeter is the distance around that shape. What's nice is for a rectangle, you can just count the units. 1, 2, 3, 4. 4 units here. For a rectangle, the opposite sides are equal, so this will also be 4. 1, 2, 3, 4, 5, 6, 7. We get 7 here and 7 here. And then we'll add those sides up. 4 plus 4 plus 7 plus 7. And we get 22 units. That's the perimeter of that shape. For the next one, we already have it graphed out. Count the units of the sides. Looks like 4 here. 4, so it is a square. So we can do 4 plus 4 plus 4 plus 4. You could do 4 times 4, whatever you want. And we get 16 units. Okay, number 7, now we have a triangle. 2 of the sides are just like horizontal and vertical, so for those we can count the units, but for the diagonal we're actually going to have to calculate the length. So for the ones that are straight, I'll find those first. 1, 2, 3, 4, 5. Before we get to calculating anything, what is like a guesstimate of how long this is? What would you guess? Like, how long do you think this is?
Oh, that?
Yeah.
Like 9 or 10.
Okay, 9 or 10. Let's just say it's about 10. If you were to add these three up, you would get 10, 15 plus 8, 23. So we're going to get an answer around 23. If we don't get an answer around 23, we did something wrong. Also, if you're working on multiple choice, you're on the SATs, you're short for time, make a guesstimate. And if there's only one answer choice around 23, just choose it. So by using estimation, sometimes you can narrow stuff down and get stuff right on something like the SATs or standardized testing where you're really pressed for time. On the FSA, they really don't press you for time, but the SATs or PSATs, they definitely do, and you want to have quick ways to do stuff if you need it. Okay, so we're looking for an answer around 23. To find this length exactly, we're going to use Pythagorean Theorem. The way we did it yesterday was we drew a right triangle. However, this already has a right triangle right here, so we're going to use these dimensions to find the exact length. So 5 squared plus 8 squared equals c squared. 25 plus 64. Okay, square root of 89. So to find this is square root of 89. It's not a pretty number, but it is what it is. We're going to say the perimeter is 5 plus 8 plus square root of 89. And then we're going to solve it for an answer. Plugging this in the calculator here, I'm going to zoom out so you can see my calculator. Your calculator is probably different. Whoa, you can't see the screen very well. Okay, if I tilt it, you can. So I'm going to do square root of 89. I get that decimal. Then I'm going to add plus 8 plus 5. And I get 22.43. And that is my answer. It was a little bit rounded because of the decimal, so it's not exact, but that's what I would be looking for in the answer choices. And it is really close to the 23 I estimated, so I probably did all the math right. And I would choose 22.43. Oh, I should cross this out because I don't want you to think that's the correct answer. It's circled. The next one, this is a triangle, as you can see. To find the answer of this one, this vertical line, I can count the units, 1, 2, 3, 4, 5. From here, you would need to find the length of each side. And it's on a diagonal, so you can't just count the units. The way we would do it is you would draw your right triangles. Draw one right here. And then I can use that you can see what I'm doing. Okay. Then I would use that to solve for this length here. So 3 squared plus 4 squared equals c squared. Okay, we solved for it and we got 5. So that distance, I wish I had a different color to work with, but I don't. This distance right here is 5. Now for the next one, I have 2 and 1, 2, 3, 4. So I'm going to do 2 squared plus 4 squared equals c squared. I wish there was a shortcut, but there's really not. So I get square root of 20 for that length there. So that right there is square root of 20. Now to find the perimeter, I'm going to use this space over here actually. Whoa, okay. I'm using this space over here because we're not going to use it. So 5 plus 5 plus square root of 20 will be my answer. And then from there, I will put square root of 20 plus 5 equals 14.47. Okay. Another thing I'll let you take notice of, because it might save you some time throughout geometry, is there is a special right triangle. There's a few of them, but one of them is these dimensions, 3, 4, and 5. If you have a right triangle and you notice the dimensions are 3 and 4, that third side is going to be a 5. This triangle comes up all the time, so if you see those dimensions 3 and 4, don't worry about doing the calculations. You know that third side is going to be 5. So just something to take note of. Might save you some calculations along the way. Okay, now we're going to move over to area. Over here. So we're starting with, remember, area is space inside the shape. All of these we're going to be working with area. We're starting with a triangle here. Area of a triangle is 1/2 base times height. Okay, the triangle we have drawn is a right triangle, so our base is right here and our height is this perpendicular length. So the base is at 1, 2, 3, 4, 5 units, and the height is 3 units. And then we can plug that into our equation. Area equals 1/2, the base is 5, and the height is 3. Five times 3, 15. When you multiply by 1/2, there's a couple different ways to do it. The easiest way to do it in a calculator is just divide 15 by 2. By dividing by 2, it's the same as multiplying 1/2. You could also multiply by 0.5. You'd get the same answer, but 1/2 times 15, or 15 divided by 2, is 7.5. So the area is 7.5 units squared. Remember, area is the number of blocks inside of a shape. For a square, if you were in a pinch or you forgot an equation, you could just count the squares. Same with a triangle, you're just not going to get an exact answer, but if you're trying to narrow down the multiple choice answers, you could literally just count the squares. If I counted the squares, I get 4, 5, 6, 7. Yeah, it does look like 7.5 squares in there. So, worst comes to worst, you could count the squares for area. Or if you forgot the equation for area of a trapezoid, try counting the squares. 12. We have a triangle here. Area of a triangle is 1/2 base times height. For this triangle, we're going to look at it upside down. I noticed that this side of the triangle is right on the line, and I could just count the squares instead of trying to calculate a dimension. So this I'm going to use as my base, and it would be 1, 2, 3, 4, 5, 6, 7 units. So that's my base. And then the height, I need the length from the base to this top corner, and it needs to be perpendicular. So I'm going to use this line right here. That's my height. So I'm looking at it upside down. Counting these segments, I got 1, 2, 3, 4, 5, 6, 7. So this is 7 as well. And now I have my base and my height, and then I'll plug it into the equation. (49 times 1/2), or 49 divided by 2, comes out to 24.5. We just have a square. Area of a square is just side times side, or length times width, however you want to think about it. We have 3 units here, 3 units here. So it would be 3 times 3 is 9. Area equals 9 units squared for this one. And then parallelogram. The area of a parallelogram is base times height. Base is this length here, And then the height is the perpendicular height. So it'd be like this. So it's 2 units for the height. And then the base is 1, 2, 3, 4, 5 units. So area equals 5 times 2. These other examples are pretty high level. It's the same process as this, but you're taking each part apart and finding the area of each one. We're not going to work through each step, but that's the process. It's the same as this, but it's breaking it up into pieces and then putting it all together. So whatever the area is of this, you'd add it to this and add it to this. None of the questions on your homework are that high level. If you're like a level 5 student that likes to challenge themselves, go ahead and give it a try and see if you can get the correct answers. Here is the answers if you want to take a hack at it. But I'll leave that up to you. So if you finish the homework, it's super easy for you and you want to feel like challenged today, you can go ahead and try that problem if you'd like. So for the rest of class, we are going to work on our homework on Schoology, and then if you finish that, work on your Khan Academy. I know a lot of you in this class have finished with Khan Academy already for the week, so good job on that. Because we're having issues with the internet still, you can use your phones, so you can take your phone to your desk. I do want to see everybody working on their homework, though, so when I look at Schoology, I should see everybody logged in.